In part 6 of Modelling Fundamentals for Power ProStructures, we're going to look at the plate objects and all the things we can do with the plates. Now, plates are an amazingly flexible object within the ProSteel environment. We can use them for so many things. They're not intelligent or as intelligent as the shape objects, because the shape objects are driven from a database, where plates are, in effect, a dumb extrusion. But the amount of things that we can do with them is quite amazing. So let's run through some of those things. The plate function is found under the ProSteel tasks here at Q2. Okay. Like everything else within ProSteel, it's dialog box driven. We have a new number of tabs across the top here: straight plates, arc plates, web grating, which runs on a user database. You can see here somebody has set it up, and a path to where that database lives. To be honest with you, my grating, I manually draw it in. I don't run it out of a database. So we'll look at straight plates. We'll have a run through that in this session. We can define numerous things about our plate: a length, a width, the thickness. We can pull that out of a list or manually type it. And it all depends on how we insert our thing. So how we insert our plate. If we were to insert by multiple point, just the thickness comes into play. If we were to insert by a polyline or polygon, again, just the thickness comes into play. If we insert by a center point, length and width and thickness come into play. Corner to corner, again, just the thickness comes into play. So depending on how we insert our objects, really depends on which of these fields come into play. Okay. We can change the height offset. Let's say that I wanted to put like a footing and I had X amount of grout. I can change the height offset to a negative or positive value. And it's very important that we set a name or a label. Okay, we have concrete and concrete panel, grating, stainless steel, plate, timber, all sorts of stuff within here. Okay, so it's very important that we label our plate. Additionally, what's even more important is that we give it a material grade, because a material grade gives it a specific gravity. Okay, everything from aluminium right through, there's a full catalog here of web forge grating, and the specific gravity for each object is set so that if you put something a meter by a meter, the mass of the object will come out correctly. Okay. So in this instance, I want a plate, so I will set the material to grade 250. Like the shapes, we don't set material, the detail style, we don't set the description. Okay, we just put our object in initially. So the key things are thickness, label, and material. We can change the level. Okay, by default, it was set to configuration value, which we'll put it on a plate layer, but I've got Pro Concrete, so I've got a lot of levels in here. Okay, but PS Concrete is specifically one I've put in for people with ProSteel that want to draw concrete objects. Okay, in this instance, again, I'm just going to draw a plate, so configuration file value will be fine. The other thing too is insert edge. If I put it on the bottom, it would be grating, right? So it goes from steel, top of steel, up. If I put it on the top going down, it would be like a footing. Okay, if you could put it in the middle, who knows? Okay, top and bottom are the common ones. All right, so in this instance here, I'm just going to go for a plate 600 by 600 by 20 mil thick. Okay, inserted by the center. Now, like the shapes, if you change it without closing out of here, it will update. Okay, so it's very important. Don't muck around in here unless you really want to make an alteration to your plate. Okay, by ticking OK, that's now locked. All right. So let's have a look at some of the other ways that we can put it in. Okay, by series of points. Okay. This is really good for putting in, making chutes and hoppers and things like that. All right. two corner. This one's really good for grating. All right, I put my grating in like that. I just picked the two corners of the beam. This one here is really good for base plates. Okay, so depending on which ones of these you want to use, it really depends on the job that you'd like to do with them. Okay, so I'm going to insert by a polyline or polygon now, so I can just draw a free-form object. Okay, insert plate by a polyline that I pick, bang, in it goes. It is really that simple, and they're very, very user-friendly. If I need to change the shape, the plate, you can see that I've got nodes or handles, one in the middle and one on each corner. If I grab the one in the middle, it will drag out square and true. If I drag one from the corner, it will distort and jump out of shape. Okay, so things like that to remember if you need to change the size of it. Occasionally you can grab the center ones depending on the insert method, and you can actually change the thickness of it as well. So let's say that we'd like to put a base plate in here. Now I would normally use an automatic connection for this, not draw one manually, but just for the exercise, let's put one in at say 320 by 180, 20 millimeters thick. I want to make sure my label's right, the material grade is correct, and I'd like to insert it from the top going down. I'm going to insert it by the center point of an object, or where I nominate, and you can see there I just pick the centroid of the column. It really is that simple. Okay, very, very user-friendly plates. All right, so let's what else can we do with this? We can draw not just plates, but we could draw plate objects and call them something else. So in this instance, let's put a slab down. So let's go 150. I need to give it a label. Okay, so I'm going to call it concrete. Material. There'll be concrete in this list here somewhere. Here it is. Okay, and let's set our level, just so it comes out looking not like a plate, to PS concrete. Okay, we want to make sure our insert edge also is from the top going down, and I'm going to insert it by multiple points. Now here is where my tentative snap comes in. Okay, left and right click together. All right, left and right click together, except, left and right click together, except. Okay. Really easy. This is where this practice for your snaps come into play. And I can either choose to go and pick that other corner, or you can see up the top there, my object selection is switched to, do I want to close it? I have an option there to close. And you can see I've got a little graphic there on the right saying that it's inserted. Okay. The height offset, I could also put that in as a positive or a negative value. And if you watch, you can see that the on the screen is live. Okay, so we've got a gap there now underneath. All right, now I understand that that isn't quite perfect. This is the beauty of plates. I can just drag this around. So in this instance, let's go, we'll lock it in this plane by hitting enter, and let's go 250 millimeters out. And I'm going to do this with all. So lock it by hitting enter, 250, and pick the side that I want it to go on. Lock it, pick the side, 250, and pick the side I want to go on. Okay. 250, and I'm going to go 250 all the way around here. Okay. It really is that easy. There we go. There's our slab. How easy is that? All right, let's go one step further. What if we've got a pier underneath this column here? All right, so let's go, say 450 by 450. Our thickness may not be in the list. We can type the thickness here. Let's go 600. The height offset, let's leave that at 40. It is still concrete. Okay, and the level's correct. Okay, I want it from the top going down. and pick the center of my column. Okay, or in this instance, I'm going to pick the grid. Okay, it does a fantastic job. And this is the plates. All the different things we can do with plates. All right. Well, let's go one step further. What else can we do with plates? How about tilt panels? Now, one of the things we've got to be really careful about tilt panels is we normally get a plan view of our tilt panels. Okay, so what a lot of people would do is they go, I want a thickness of 3500 high, I want to make it a concrete panel, and I'm going to just pick the polyline that I've drawn. Okay, and your panel comes up. Okay, oops, change that to bottom. There we go. Okay, so there we have our tilt panel, and it looks terrific. The only problem is that it has one inherent flaw. It has gone from the bottom up. And if we have a look at the properties of this object, okay, it doesn't stand out so much here in the name, but once we go to the values, you can actually see that the length by height or width and the thickness are back to front. Okay, the thickness is incorrect, which means it's going to present incorrectly. It's going to on the part list and so forth. Okay, so that is not how we want to draw our tilt panels. How we want to draw our tilt panels is from inside the building looking out, not looking down on top. And to do that, we've got to roll the ACS around. Okay, all right, so that's this little guy here. All right, and we could just rotate it round by a set degree. All right, so it'd be easier if we're looking at this here, and let's go rotate, and I want to rotate the X right around the X-axis by 90 degrees. Click in the model space, and you can see it just spun around on the X, okay, by 90 degrees. Now, once we're modeling our tilt panel, we're modeling from inside the building looking out, okay, and it's going to present the tilt panel completely differently. Okay, so instead of having a thickness of 3500, we'll put in 175 thick and draw it as a rectangle. Okay, and what I can do is I can just I can nominate a figure in there, but I could just click on one corner, and I could actually just use my AccuDraw to tell me what distance across or what length this panel has to be. So you can see there 4500 in the X. So I'll just type in 4500 by 3500 high. Okay, now that right there, here is that is how we want to do our tilt panels. Okay, it is going to present correctly. Okay, because the plates themselves also have an ECS, even though it's not turned on. And what it's going to do is it's going to detail this front face on a sheet when it details. So this inner edge here will be pointing up towards us, which is how we actually want the panel to project. And not only that, you can see that the values here are going to present correctly in our lists as well. Okay, so something to keep in mind. If you have other panels, don't forget we can copy them around, and we can stretch them and by grabbing the little handle points. Okay, I mean, in this instance, everything is all the same. Once you've got to change a direction, though, don't forget we've got to move this ACS, okay, and we've got to spin it around so that we're inside the building looking out. So in this instance here, I want to spin it not on the X, but I want to spin it on the Y, okay, and I want to spin it clockwise, so it'll be minus 90 degrees, and click in the model space, and you can see it spins it around. Okay, so let's just have a look at that. That shows it right there. Okay, so we're technically inside looking out now, and that's how we want to draw our panels. Okay. Now we could have actually used like object view centered or something like that. Sorry, object ACS centered as well. There's lots of little tools we could have used in that instance here, but And don't forget, in this instance here, check that AccuDraw up in the top right there, because it'll give you the values that you've got to put in. Okay, or you could lock it and use your use your snaps. Okay, that's how you draw panels. It's super easy. They're going to present correctly. All the data's going to come out right because we gave it the material grade concrete. The actual value, the weight value, that is correct for that panel. Okay, so all of this information is now correct. Okay, super easy and really nice and friendly to use. All right, let's go to the next type of object that I want to show you, and that would be a hopper. So, or not specifically a hopper, but let's go like an outload chute from something to a conveyor. Okay, so we kind of got a offset squared around here. You can see I've just got to reset my ACS. So aeroplane resets everything. Okay. Okay, so I'm just going to draw a long feed chute here onto my conveyor. So a long rectangle. Okay, and the inload might be, let's just draw a square. Okay, so we'll just draw a square over the top of this. Okay. I'm not even caring if it's in the center because it won't matter. Let's lift this up. I'm just going to lift it up a nominal amount. Okay. There we go. That looks good. All right. Now you don't have to do this, but I like to kind of flesh out a bit of a wireframe just to sort of see where I'm going with it. It's a little bit easier if something's twisted as well. Okay. All right. Now what we're going to have to do is we're going to have to set our ACS to those faces or planes. Okay. And the way we're going to do this is by 3 points this time. Okay. So by points, okay, and we're going to have to select 0, positive X, and positive Y. So I like to make my positive X like flat along the bottom. So there's my positive X and positive Y. Okay, my ACS is now set to that plane. All right, so I can just come up to my plates. Let's go 8mm plate. It is a plate this time. Plates material grade would be grade 250. Okay, we can set our level to the configuration value. All right, and I'm happy with that insert edge. Okay, so I'm going to select by points this time, and you can see that I'm going tentative snap, accept, tentative snap, accept. So, and we've got a little close button up there. Okay. In our panel goes. Really nice and simple. So I'm going to reset by point again. 0, positive X, positive Y. Okay. Drop our plate in by point. Tentative snap, accept. Tentative snap, accept. Okay, and then close up the top. How easy is that? Okay, really nice and simple, does a beaut job. Okay, there's a couple of different ways we can do that, but this is the way I like to create my my feed chutes. And don't forget that aeroplane will reset everything too. Okay, so let's get rid of that hopper or the feed chute. Okay, and let's reset this time for grating. Okay, I'm going to show you how to do grating. Now we have a WebForge catalog in here. All has the specific gravity for each particular WebForge type so that the mass per square meter comes out correctly. So I want 32mm grating for C325MP. I'm going to pick it by corner. Remember, toggle the focal point by E. Okay, and it drops your panel in. Now, if I go to the properties of this layout, okay, you see down here there's a grid switch. And that will actually tell it will put the grid pattern in, a grid marker for you. Okay, so it presents like grading. Okay, And that'll come out in the detailing as well. It'll put a little direction marker and everything on for you. Now, when I was putting in the plates, I've got a switch here for grid. That is not where I put it in later, because otherwise you end up with the grid coming out on things like base plates and all sorts of stuff. Okay, I always put my grating in first, then I put my marker in. So that's it for our plate session. I hope you enjoyed that. Very, very useful plates. They're really user-friendly. They're not the smartest things, but they're certainly, you can do anything with them. All right, so go and have a practice with that and have a bit of fun with that. See you in the next session.